All right, guys, we are on to, there we go. The next section in your packet here, now that you know about square roots, you know about cube roots, we're taking it to that next step, solving equations with square and cube roots notes. So first thing I'll do is fill in these notes off to the side here. It says remember, and before I even finish filling in these blanks here for these little phrases to help you remember, first thing I want to say is to remember that when we're solving equations, we always do the opposite, right? Our goal is to isolate the variable, to get that variable by itself. So here, what it's really asking me to do when it says remember if you have x squared, then what they're asking is how do you do the opposite of that? What are you doing to get that variable isolated? So if I have x squared, then I'm going to take the square root. While I'm still on Eraser. And then we'll just go and put the symbol there just to remind us, right? If I have x cubed, I'm going to take the cube root of both sides. And remember that one looks just like the other one, a little check mark with a roof, except it has the number 3 up there, okay? If I have the square root of x, like if the equation actually says the square root of x, to do the opposite, then I'm going to square both sides. And then finally, if x is part of a cube root, so if I have the cube root of x, then I'm going to cube both sides. And again, that's because these are the opposites, right? To solve an equation, we know to do the opposite to get that variable isolated. So here for example number 1, I'll zoom in so we can see that a little bit better. All I'm going to do is just draw my wall, right? Separate the two sides, and then see this is a one-step equation. X is being squared, so I do the opposite. I take the square root of both sides, right? If I take the square root of both sides, picture it like this: that square root symbol, almost forgot the word, and the squared cancel each other out. Boom. The only thing that's left is x, right? And then the square root of 16 was 4. And then I'm going to use our new sign to include that it could also be -4, right? It could be positive or -4 that would equal 16. For example number 2, same thing. It's just now this is a two-step equation. Draw your wall. Always get rid of that plus or the minus first, right? So that -7, I got to get rid of it. Trying to isolate that variable, so I need to get rid of the numbers that are by it. I'm still left with the cube root of x equals 8. The opposite of the cube root, I lost my train of thought there for a second. The opposite of the cube root of x is to cube both sides. So I'm going to go ahead and cube this side and cube this side, right? The cube root symbol and the cubed cancel each other out. I'm left with just x. Okay, and then 8 cubed, remember that's just saying 8 times 8 times 8. I'm using 8 when I'm multiplying 3 times. Well, 8 times 8 is 64. And then 64 times 8, it is eluding me right now, so let's just go ahead and work it out. There we go. That's right. It's 512. So x equals 512. And that one only has one answer. With cube roots, for sure, we only have one answer, but also we were working backwards, so that one only has one answer. For example number 3, again, it's a little two-step equation. I'll go ahead and draw my wall. The y is being multiplied by 4 and it's being cubed. We want to get rid of the multiplication first. So that multiplied by 4, I'm going to divide both sides by 4. So when I divide both sides by 4, I get y cubed equals, oh my goodness, I'm sorry guys, my phone is blowing up right now. Twice to 27, my goodness, it's making me lose my train of thought. Y cubed equals 27. The opposite of cubing a number is to take the cubed root. I'll change my color here. I'm going to take the cubed root of this side, and I'm going to take the cubed root of this side, because that cubed root symbol and the cube cancel each other out. I'm left with just y. The cube root of 27, we actually did that in the notes on the last section, is 3. And for cube roots, we only have one answer. Now, for example, number 1 up above, we had 2 answers. It was positive 4 and negative 4. But for a cube root, we only have one answer. All right, for example number 4, it's just another 2-step equation again. I'm going to go ahead and subtract 4 from both sides. Get that variable by itself. I have the square root of a is equal to 4. And some of you are thinking, oh yeah, square root of 4 is 2, so the answer must be 2. But remember, we have to work backwards here. It's taking the square root of a. Well, the opposite of taking the square root is to square the whole thing. So I've got to square both sides. Well, when I square both sides, I get a equals 16, because 4 times itself, 4 squared, is 16. So I've got this example number 5 here, and it looks like a 2-step equation just from what we've experienced in the past, but it's actually a 3-step equation. I've got to do 3 separate things here. Okay, hold on just 1 second, guys. Never had that happen, did you? Where the teacher just left in the middle of the video. My phone was blowing up, so I just had to get rid of it so I could focus on what I'm doing. All right, here we go. Draw our wall. Like I said, it looks like a 2-step equation, but it's actually a 3-step equation. The first thing I'm going to do is subtract 5 from both sides, and that gets me 2b cubed is equal to 128. And this is where the third step comes in, because now we would just divide both sides by 2 and we'd be done. The variable is by itself, but it's not here because it has that exponent. So I'm still going to divide both sides by 2. It's just that's not my final answer. I still have b cubed equals 64. So 128 divided by 2 is 64. Now I'll change colors again. Let's do orange. If b is being cubed, if the variable is being cubed, I've got to do the opposite of that. I've got to take the cubed root of both sides. So that cubed and the cubed root symbol cancel each other out. I'm left with b equals, well, what number when I use it 3 times equals 64? You guys could just use your calculators, but we did this in the notes on the last section. It's got to be 4. Right? Because 4 times 4 is 16, and then times that by 4 again, and it does equal 64. All right? And that one only has one answer. Again, I can't stress that enough. With cube roots, it's one answer. For square roots, that's when it could be 2 answers, right? So for the negative examples, on the next page, it has a squared plus 12 equals 3. Well, let's go ahead and solve it. We've got subtract 12 from both sides, and that gives us a squared equals 3 minus 12 is negative 9. I know the opposite of squaring a number is to take the square root. So I'm going to take the square root of both sides, and boom, right there. That's when I notice it. I can't have the square root of a negative number. I can have the cube root of a negative number, but I can't have the square root of a negative number. Okay, so this one is not possible. Now for This example, notice it's different, right? It's b cubed, so it kind of gives it away what's going to happen here. I draw my wall. It's another three-stepper. I subtract 50 from both sides. I get 3b cubed is equal to negative 648. And then divide both sides by 3. We get b cubed is equal to 216, negative 216. Now, the opposite of cubing a number, I know, is to take the cube root of that number. So I'm going to change my colors here. I'm going to take the cube root of both sides. And this time, it is okay to have the negative underneath the cube root symbol, right? The cubed and the cube root symbol on the left cancel each other out. We're left with just b. And then the cube root of 216, what number multiplied by itself used 3 times would give us 216? And that answer is negative 6, right? Because negative 6 times negative 6 is positive 36, and then positive 36 times negative 6. That's how we get that negative, because a positive times a negative is a negative, and it does equal 216. All right, only a few more examples left to go here. For example number 8, I scrolled past the directions. Find the mistake examples. So I'm just looking for their mistake here. For example number 8, let's see what they did. I've got x squared plus 12 equals 48. They subtracted 12 from both sides. Beautiful. I don't see any problem with that. And then they didn't show it exactly. Let's write that in for them. They went ahead and they took the square root of both sides, right? Take the square root of both sides, we get x equals 6. What's the mistake? Square root of 36 is 6, except they didn't account for both answers, right? They didn't provide both answers. Because remember, there are 2 numbers that when I multiply them by themselves will equal 36. Let me finish writing my answer here. And that is positive 6 and negative 6. So just that new sign that we learned, I'm going to use that to show both answers here. When I take the square root of 36, I actually get 2 answers, positive 6 and negative 6. All right, let's see what we did here for example number 9. This one, I'm gonna draw a line here just so we can see the actual original equation here a little bit easier. The original equation here is the cubed root of y divided by 2 equals 32. So you can see what they did first. They went ahead and multiplied both sides by 2. Perfect. No problem with that. That leaves us with the cubed root of y equals 64. Well, we know that the cube root of 64 is 4, but that's not what it's asking us, right? It's asking us, what number, when I take the cubed root of it, equals 64. So for this one, we've got to do the opposite. And again, they didn't show their work on example 8 or example 9. I don't like that. Let's go ahead and put that on here. What they should have done is cubed both sides, right? Because that cubed gets rid of the cubed root symbol, and that's how we get y by itself. Well, 64 times 64 times 64 is not 4. Okay, so what was the mistake? They didn't do the opposite. They just took the cubed root of both sides. Well, that's not how you get y by itself. You have to do the opposite, right? So they didn't do the opposite, or they didn't use inverse operations. Not inverse, but inverse. And then what is the correct answer? This is where maybe I wish I wouldn't have put my phone out in the hallway. we've got to do 64 times 64 times 64. In fact, seems like this is a good opportunity for you guys to get your calculator skills under control and go ahead and do that. So go ahead and do 64 times 64 times 64. Put your answer there, and yeah, then you're ready to move on to the practice problems. So we give you plenty of room, guys. Draw your wall, show your work, make sure that you're showing that you're doing the opposite, right? Don't be like example 8 and example 9 where they are not actually showing what they're doing. Show that you're taking the square root of both sides, or show that you're cubing both sides. Show us your work here. Okay, and then it does say if you happen to get a decimal, just round it to the nearest tenth. All right, make sure you ask your teacher if you have any questions.